Okay, we're going to go ahead and continue with the central nervous system. And I could not remember if I had said this correctly whenever you were watching the last video, so I'm going to go ahead and mention it again. Superficial and the middle and the deepest layer there of the meninges. Make sure you remember superficial, that is the outside layer. So the arachnoid is in the middle, and then again the deepest layer, the pia mater, is closest to, let's go here, so closest to your blood. I'm not sure if I had mentioned that before, but so again, moving on. So we've talked about the different regions of the brain. We got to the cerebrum and the frontal lobe, parietal lobe, temporal lobe, occipital lobe. Now we're going to move on down to the cerebrum. Okay, so this is where we left off. So the functions, mainly here is the motor cortex, and if you think motor, think movement. And then there's the sensory cortex, and just think senses. Okay, so again, frontal lobe is at the top, parietal lobe is at the back, temporal is sort of like in the middle, in between what they call this small brain, which we'll get into a second. Occipital, the vision part, is in the back. So y'all will eventually build a model of the brain, but just so you understand what the cerebrum, the functions, that has to do with movement, and then also the senses. So the motor cortex of the cerebrum, so it's at the back of the frontal lobe. Okay, and it goes from ear to ear across the top. So I don't know how you want to remember that, but you can kind of see here, or it's not actually on there. Never mind. Okay, so it's the back of the frontal lobe, but I'm not going to ask you to actually label that. So what's interesting about this is, you've probably heard of left brain and right brained people, but what that means is the left brain, which is interesting, controls the right side of the body. And the right brain controls the left side of the body. Okay, so the more precise, what it means more precise the movement, the more space is needed to control it. I'm not going to ask you about that. Just kind of understand big picture that one side of the brain actually controls the other side of the body. Now, just to kind of give you an idea of how this works, I think it's pretty interesting. So right now, if you're watching it, move your hand in a circular motion like you're polishing a table. So just kind of movement in a circular motion. So keep doing that. And then start moving your right foot in the same motion that you're doing with your hand. So do that for a couple of seconds. And then reverse the foot motion. So move it in the opposite direction of your hand. It took me a while to actually be able to do that. But if you do it the other way, so you're moving your right hand in a circular motion, go to the other foot and see if you can move it in the same direction. And it is a lot easier because the left and right limbs are controlled by opposite sides of the brain. So the opposed activities, they would interfere less with one another if it's on one side and the other side of the body, which is pretty interesting. So that's just kind of to show you that the right and the left brain have what influences they have. So again, moving on with the cerebrum. What's interesting, if a person has a prosthetic leg, for example, those nerves are no longer there, but they can move it just by thinking about it, what is interesting. So there's actually electrodes in the brain that record it and then help operate that prosthetic by just thinking about moving it, they can move it, which is pretty interesting. That's kind of a side note. So the cerebrum again, so now we're talking about the sensory cortex, not the movement part, the sensory part. And anterior to the parietal lobe. So just remember those terms again, anterior versus posterior. So it's in front of the parietal lobe, and it receives incoming information from the skin and body parts. So that would be, you feel something hot, and that's what you sense, and your motor cortex actually does the movement part. So the larger the area that it's devoted to, the more intense the sensation, which makes sense. Like a larger portion of your hand is being burnt, then the more intense it would be, as opposed to if it were just a small area of your hand or finger. Okay, so now moving on again with the cerebrum. So the hemispheres, and you think of, the hemispheres like the northern hemisphere and southern hemisphere of the globe. It's just different sides of the brain. So lateralization is the hemispheric. Specialization. So how specialized the different hemispheres or parts of the brain are. So the left side, so moving on to like left brain people and right brain people. The left, that's the language, also like arithmetic or math, reasoning. And then your right brain is more like perception, like spatial skills, what else? And again, another one we talked about earlier, face recognition. Okay. So the corpus callosum, that is what actually connects those two hemispheres together. So the right brain and left brain, what's actually connecting the two of those is a fiber called the corpus callosum. And you may have heard of epilepsy. So that's a brain disorder that a person has seizures, uncontrollable seizures over time. And that disturbs brain activity. And especially when they're younger, it can delay development. And it can change their attention, especially if there's all kinds of different seizures. You don't have to need to know these, but like tonic, clonic, there's all sorts of different types that can be there, but it can change whether or not somebody's attentive, whether or not they're kind of staring off into space, and then behavior if it's a severe, what they call a grand mal seizure. So what would happen if that corpus callosum were actually cut? So think about that actual fiber connecting the two hemispheres. If they were cut, what's interesting is that it does stop communication between the hemispheres, which makes sense. Okay, so that stops. And they did this. What would happen if it were cut? There was an experiment done on somebody who had severe epilepsy. And what they found, so they split that corpus callosum. So the split brain patients were completely no change in personality. There was no change in how smart they were or the intellect. But what's interesting is how the visual field works. So remember, right side and left side, that's the only thing that kind of did change. So they asked those patients to stare at the word heart, and that's on the next slide. But if you're looking at it, he was it's on the left visual field, which is actually, we know, controlled by the right hemisphere of the brain. And art, that next part here, is controlled by the left hemisphere of the brain. So when they asked what they saw, and then when they were asked to point, different things started happening. So when they asked what they saw, they said they saw art. But when asked to point to the word, their left hand pointed to he, which is interesting. So in normal brains, if they would have said heart and pointed to heart, but in these patients, the communications wasn't there, so they would see HE, but then they would point to ART. So that's just an interesting, side little note. Now, handedness. Okay, so moving on to left-handed people versus right-handed people. Most people, by far, are right-handed. They're about 10% of the population are left. So I'm going to kind of just skip down to this part right here. There are left-handers can have more reading disabilities. Not always, but they can have more reading disabilities, allergies, and then also they're more susceptible to migraines. But they are more common among musicians, let's see, architects, artists, and even professional basketball players, which is interesting. So just, again, side note. The next part of the peripheral nervous system we'll talk about is the diencephalon, and that is what controls many of those, what they call autonomic, so automatic, things you do automatically without thinking about it, functions of the peripheral nervous system. Okay, and again, there's 4 parts of this: the thalamus, hypothalamus, the pituitary gland, and the pineal gland. So here we go is the cerebrum we talked about. That's by and large, this big, large portion of the brain. The corpus callosum, remember that's what connects the right and left sides. Ventricles, I won't ask you about. Thalamus is here. Pituitary gland is here. Cerebellum we haven't gotten to yet, and the brainstem we haven't gotten to yet, but it's here. So let's go ahead and talk about the thalamus first. So it plays a key role in sensation. Mediating sensation. So it receives, gets that information, or I'll say the sensory information, and sends it to the region of the brain that processes that sense. Okay, except for smell, that's different. But like vision and hearing, which is pretty interesting. So it plays a role in, you receive a sense, and then it is what actually sends that information to where it needs to go, so that your body knows what to do with it. The hypothalamus is the next one, so that's below the thalamus, and it regulates, here we go, the autonomic nervous system. So things like body temperature. So, your body gets too cold and you start to shiver. Another thing, food intake. You get hungry. Monitors blood chemistry, and those are what they, and another thing, what they call the reward center. So those things would be things like alcoholism, drug abuse, something else, and like binge eating. Those can stem what they call from a reward deficiency syndrome. So people could be genetically disposed to have a pleasure system that would lead them to crave certain items, but that could be a sort of something wrong, I guess you could say, with the hypothalamus. So lots of things could be binge eating, it could be hoarding, things like that would be a all in the reward center, like what makes somebody happy. That's in the hypothalamus. The pituitary gland, that's the supervisor of the endocrine system, which we haven't learned yet, but there's different glands and they send different information to different parts of the body. So your thyroid is one example, your thyroid gland. Your adrenal gland is another one. Your sex organs, that's something else. So that's what actually controls the sending of information that would cause things like testosterone and estrogen, things like that. So it's the pituitary gland. So the cerebellum is the next part of the brain, which we'll get to. But again, I'll go ahead and stop there, and then that will finish up the central nervous system. So we'll go ahead and stop.